So the next thing to explore is the effect of time. Time increases, cost increases. That's basically the definition of inflation. And that is what we are risking in our economy, right? That the value of the money increases with time as the economy becomes stronger. Inflation is a measure by cost index, and we are going to be looking at those index in a moment. Numbers are based on baskets of goods, typically for construction of chemical plants. So this is an example from the Paris, I think. On the right side, this is how you can calculate what we call the Chemical Engineering Plant Cost Index, which is the cost index that we're going to be using in this class. I call it CEPSI. This is the CEPSI value. So this is just examples of the weighting component, right? How much the different criterias of the index, right, are weighted and how much importance. So notice that equipment, machinery, and supports add up to 61% of the total weighting of the components. So you can see that it is heavily related to anything that is related to the equipment, machinery, and support. You also have 22% related to the erection and installation of the labor, right? Putting the equipment in place. Also, the building materials and labor. We have to pay people to install it. We have to buy wires. We have to buy duct tape, I don't know, things that you need to actually set it up. And then you also have engineering and supervision, which is the payment that is a shared cost between multiple projects, but you typically include it there in your cost. The different magazines collect a lot of data across the many industries, so that's why you have multiple cost indexes depending on the industry, and that data is updated every year. Okay, so right now we have for sure the 2020 data, so 2021 is not yet published. It happens every quarter, and we don't get the final, everything is an estimate in the current year until we get at the end of the year when we get the final value. This is a comparison of all of the different cost indexes. We have the Marshall and Swift equipment, the Nelson Farrar, the chemical engineering plant cost, or the CEPSI, which is the one that we're going to be using in this class. You have the Engineering News Record Construction Index, Federal Government Consumer Price Index. Remember that depending on the industry that you are, the value that you're going to use should be relevant to that industry, especially because the components for the calculation typically are more related to that particular industry. So this is just where you can find this information. So for the CEPSI, they're typically published monthly in the Chemical Engineering magazine. They're frequently used for capstone design and chemical design when you have chemical processes. You also have the Marshall and Swift equipment costs, and they are also published for chemical engineering magazines. You have the Nelson Farrar Refinery Cost Construction, the Engineering News Record Construction Index, and you can find where you can find them. Okay, once again, we're going to be using the CEPSI in this class. So to relate the cost that you need with the cost of an equipment that you know and the corresponding CEPSI value, right? Or cost index value, you can use this equation. Notice that it's really similar to the one with the attribute, but we don't have an exponent. Please be careful. But the idea is the same, right? You're trying to determine the cost of two different points in time. So let's say that we're trying to get the CEPSI value for 2021, right? 2021. You're gonna use the 2 will represent that number, right? That cost for that year, and then the 1 will be the year that you have reference for. So let's say that you calculated the heat exchanger area for 1985, and that's the information that you have with the same capacities, the same equipment, same capacity. The only difference is this time scale, right? So we are just comparing here the same equipment at different points in time. That is really, really important. So this is what I have, right? So for available CEPSI annual values, I update this every year. So right now we are in 220, and the last one that we received for last year is 597. I think this is still preliminary. I'm not sure if this is the final one, but it's pretty low compared to the previous year just due to the pandemic. So every year I update this graph, or this table for you. You can have it available on your slides. Let's view some examples. So this is for a vessel, right? We're going to calculate, we have information about the cost of vessel in 1993, and that cost was $25,000. the question is, what is the estimated cost today? And that today, right, corresponds to December 2016. So the CEPSI value for 2016 is given by 242. So what we're going to do is basically use the equation or the relationship between the cost index and the cost of the equipment. Remember, this is assuming the same equipment with the same capacity and the same materials of construction and materials of construction. The only thing that we're changing here is the time, not the capacity. So in this particular case, notice that in 1993 is 25K. Now the cost is increased, right, because of the CEPSI value and the inflation, right, of the prices in that time frame. So the cost right now is almost 38K. It has increased. And the capacity hasn't, right? It's just time. So here, right, another example, you have taking into consideration both time and size. So here you have information about two heat exchangers, one that was bought in 2000 and the other in 2010 for the same service. And here the same service is critical again. Remember that same service means that is the same type of process conditions that you're going to use in both. Affecting the pressure factor and the materials of construction. So that's a big assumption here, and it's important for your assumptions when you do this type of calculations. So example, equipment A and B, right? You have the area, the differences in area, 70 meters square and 130 meters squares. You have the time when it was purchased and the corresponding price for that time. They also give you the CEPSI value for that particular purchased. The question is, what is the cost of an 80 meter square heat exchanger in 2006? So they also give you the CEPSI value for 2006. So I recommend you to quickly pause and think about how to do this and then get back to the solution. A good strategy here is to start with the time. We can convert both equipments to the same time frame. It could be for the one that the statement is asked us for. So we convert A and B to the same time of 2016, and then we deal with the capacity. For the capacity equation, we can assume is the easiest way to calculate. Assume exponent equals to 0.6, so using the 6/10 rule. Or because we have enough information, we can actually calculate the exponents ourselves. So let's do this. So again, we're going to first bring all of the equipments to the same common time. So we're going to change it to the 2016 time. So this is the corresponding prices for 2016 of these two equipment with different attributes, different capacities, right, in the area. Then the next thing is to calculate, right, the exponent for the equation to calculate the relationship between the two capacities of the same equipment. Notice that after calculation, you get with a number that is really close to 0.6. So when you don't have enough information like we do here, it's okay that you use 0.6. But if you do have the information, just use the most precise value, right, based on the information that you have available. Remember, the more assumptions and error and estimated values, the more error will carry to the final estimate that you do. So here in this case, right, we calculated the exponent, and then we use the equation relating the different capacity, and we end up having that the cost for the new capacity will be 17,420 for the new equipment, which is they're asking us for 80 meter square equipment. Okay. So once again, you go back and forth between these numbers. It's pretty easy going and straightforward. You just have to make sure that what you're doing, right, is the correct thing. And I think one of the biggest mistakes is that we compare capacity at different time frames, and they have to be at the same time frame. And then we deal with the capacity, okay? You have two ways. Assume the n of the equation of capacity to be equal to 0.6 if you don't have any enough information. But if you do have information, make sure to calculate it.